June 1943. A small apartment in Brussels. British agent John Louis pedals a stationary bicycle in his bedroom corner, sweat dripping down his face. To any neighbor glancing through a window, he's simply exercising, common during wartime when food is scarce and people stay fit however they can. But John Louis isn't exercising. He's charging a battery. And that battery powers a radio transmitter hidden in his closet, about to send coordinates for a German ammunition depot to London. The bicycle looks completely ordinary. Worn leather seat, rusty handlebars, chipped paint. It's positioned on a wooden stand, elevating the rear wheel off the ground, allowing the wheel to spin freely while the bicycle remains stationary. But attached to the rear wheel, hidden beneath a cloth cover, is a small electrical generator connected to wires snaking under the floorboards to radio equipment. German soldiers patrol this street every 2 hours. They've searched this apartment 3 times in 6 months, looking for the radio transmitter they know operates somewhere in this neighborhood. They've seen John Louis pedaling, maybe even joked, "The Belgian stays fit while we do the real work." They never suspected that every wheel revolution generates electricity, storing power in rechargeable batteries, providing energy to transmit messages to England without any connection to the municipal power grid Germans monitor obsessively. This isn't improvisation. This is British engineering genius. A pedal-powered generator system so efficient it can charge radio batteries in 30 minutes of cycling. So quiet, it produces no mechanical noise alerting neighbors or patrols. So completely disguised as exercise equipment that German technical experts examined captured examples and concluded they were simply bicycles with attached dynamos for lighting, missing entirely the sophisticated voltage regulation and battery management systems, making them perfect covert power sources. How did Britain turn exercise equipment into a power station for spy networks? How did a bicycle become one of the most critical pieces of equipment for resistance radio operations? By 1942, British intelligence faced a critical problem threatening to cripple the entire resistance communication network. The biscuit tin radios were working brilliantly, compact, disguised, effective. But they had one fatal dependency: batteries. Those batteries lasted roughly 30 minutes of transmission time before exhaustion. Replacing them required supply drops from England or risky courier deliveries through occupied territory. The supply logistics were unsustainable. A single resistance cell operating a radio needed fresh batteries every 2 weeks. With hundreds of cells across occupied Europe, battery demand was enormous. RAF aircraft dropping supplies could only carry so much. Weapons, explosives, medical supplies, food, and batteries all competed for limited cargo space. Many cells found themselves rationing transmissions or going silent for weeks, waiting for battery deliveries that never came. Worse, batteries were traceable. German counterintelligence knew resistance radio operators needed batteries. They monitored battery sales, tracked commercial battery shipments, and investigated anyone purchasing batteries in unusual quantities. In France, buying more than 2 batteries per month without authorization could trigger Gestapo investigation. Some agents were caught simply because they purchased batteries too frequently from the same shops. The obvious solution, connecting radios to municipal power, was a death sentence. German occupation forces monitored electrical consumption obsessively. They tracked power usage patterns in every building, looking for anomalies suggesting illegal radio operation. Transmitters drew distinctive power signatures, brief spikes when transmitting. German monitoring equipment could detect these spikes and pinpoint locations. Dozens of resistance operators were captured because their radio transmissions created power consumption anomalies German technicians traced to specific addresses. SO's technical section needed a solution that was energy independent, untraceable, and compatible with covert operations. The power source had to generate enough electricity to charge radio batteries, but couldn't connect to any grid Germans monitored. It had to be quiet enough to operate in apartments without alerting neighbors. It had to be disguised well enough to survive searches. And it had to be simple enough that non-technical agents could operate and maintain it. The answer came from an unlikely source: bicycle dynamos. Since the 1930s, bicycles had used small generators attached to wheels to power headlights. The generators were inefficient and produced low voltage, but the principle was sound. mechanical rotation converted to electrical energy. What if that principle could be scaled up? What if a bicycle could be modified to generate enough power to charge radio batteries while appearing to be nothing more than exercise equipment? British engineers created one of World War II's most ingenious support technologies, not a weapon itself, but a power source enabling weapons, allowing radios to transmit, coordination to happen, and intelligence to flow. The bicycle charger looked like fitness equipment but functioned as a mobile power station. And it did so with such perfect disguise that German soldiers watched agents pedaling these bicycles, examined equipment during searches, and never realized they were looking at the power source for radio transmissions they were desperately trying to stop. The engineering challenge was formidable. A standard bicycle dynamo produced approximately 3 watts at 6 volts, barely enough to power a dim headlight, completely insufficient for charging radio batteries requiring 90 volts and substantial amperage. Engineers needed to increase power output by a factor of 20 while keeping the generator small enough to hide and quiet enough to operate covertly. The breakthrough came from adapting automotive alternator technology. Instead of a simple dynamo with single coil and permanent magnet, the bicycle charger used a multi-coil alternator with a field winding that could be energized to increase magnetic flux. This design produced much higher voltage and power output from the same mechanical input. The alternator was custom manufactured to mount on standard bicycle frames, driven by the rear wheel through a rubber friction roller pressing against the tire. The alternator measured 12 centimeters in diameter and 8 centimeters deep, small enough to hide under a cloth cover or inside a modified saddlebag. It produced approximately 60 watts of electrical power when the bicycle wheel turned at typical pedaling speed. This was sufficient to charge radio batteries while also powering voltage regulation circuits, protecting batteries from overcharging or voltage spikes that could damage them. The regulation circuit was critical. Radio batteries required precisely controlled charging. Too much voltage and they'd overheat and fail. Too little and they'd charge slowly or not at all. The regulation circuit used vacuum tubes and resistors to maintain constant voltage output regardless of pedaling speed variations. An agent could pedal faster or slower without worrying about damaging batteries. The regulation system handled variations automatically. The power output was remarkable considering the input. A person pedaling at moderate intensity, roughly the effort of casual cycling, generated about 75 watts of mechanical power. The alternator converted approximately 80% of that to electrical power after accounting for friction and heat losses. That 60 watts could charge a depleted radio battery to full capacity in approximately 30 minutes. This meant an agent could restore their radio to full operational capability with half an hour of pedaling that looked like routine exercise. The system's silence was achieved through careful mechanical design. The friction roller connecting the alternator to the tire was made from hard rubber, producing minimal noise when spinning. The alternator bearings were precision manufactured to run smoothly without grinding or squeaking. The voltage regulation circuit produced no audible hum because it used passive components rather than transformers that created noise in conventional power supplies. The result was a charging system quieter than conversation. An agent could pedal in an apartment and neighbors wouldn't hear mechanical sounds through walls. The bicycle itself was deliberately chosen to look worn and unremarkable. SOEs sourced used bicycles from across Britain. Old models, scratched paint, mismatched components. These were bicycles looking like they'd been owned for years, repaired multiple times, maintained just enough to remain functional. A shiny new bicycle would attract attention. A beat-up old bicycle was invisible, exactly what you'd expect a struggling civilian to own during wartime. The mounting system for the alternator was ingenious. The alternator attached to a bracket clapping onto the bicycle's frame near the rear wheel. The bracket was designed to look like reinforcement added to strengthen a cracked frame, a common improvised repair during the war when new parts were unavailable. The wiring from the alternator ran along frame tubes secured with clips looking like wire clips used to attach bicycle pumps or lights. Even close examination suggested nothing more than an old bicycle with improvised repairs. The charging connection was hidden in the bicycle seat post. The seat post was hollow, and wires ran through it to a connector concealed inside the seat itself. To charge batteries, the agent would connect a cable from the seat to the radio battery pack. The connection was quick release, could be attached or detached in seconds. If German soldiers appeared unexpectedly, the agent could disconnect the charging cable, drop it behind furniture, and the bicycle would appear completely innocent. Alternative disguise configurations existed for different operational environments. In rural areas where exercise bicycles would seem odd, the system was mounted on actual functional bicycles that could be ridden normally. The alternator engaged only when a lever was activated. The rest of the time, the bicycle functioned normally with the alternator disengaged. This allowed agents to ride the bicycle to safe houses, park it, engage the alternator, and charge batteries before disengaging and riding away. Manufacturing was handled by small engineering workshops across England. The alternators were custom-built using hand-wound coils and precision-machined housings. Each unit took approximately 20 hours to manufacture and required testing to ensure it met power output specifications. Production reached approximately 30 units per month by late 1942, a small number but sufficient for priority resistance cells operating radio networks continuously. The chargers were expensive to manufacture, approximately £100 per unit, but the cost was justified by the operational independence they provided. A single bicycle charger eliminated the need for monthly battery drops, freeing up aircraft capacity for weapons and explosives. The systems were paired with rechargeable batteries, another innovation. Standard radio batteries weren't rechargeable, but SOE developed special nickel-cadmium battery packs that could be recharged hundreds of times. These batteries were heavier and provided less capacity than disposable batteries, but the ability to recharge them made agents self-sufficient. A resistance cell with a bicycle charger and rechargeable batteries could operate indefinitely without external support. Training agents to use the chargers took only an hour. Connect the charging cable, pedal at moderate speed, watch the voltage indicator, a small meter showing when batteries were fully charged, disconnect, and store. The simplicity was intentional. Agents operating under stress couldn't handle complicated equipment. The bicycle charger was foolproof. Pedal until the meter shows full, then stop. The psychological impact of energy independence was profound. Agents with bicycle chargers felt less vulnerable because they weren't dependent on supply drops that might never come. They could transmit whenever necessary without rationing battery life. They could maintain longer listening schedules to receive messages from London. The operational flexibility transformed how resistance cells functioned. They became proactive rather than reactive, initiating communications rather than waiting for opportunities. German intelligence never systematically identified bicycle chargers as British equipment. They captured a few examples, but classified them as civilian improvisations, agents using bicycle dynamos to charge batteries for flashlights or portable radios. The sophistication of voltage regulation systems was overlooked because German analysts assumed any capable engineer could improvise such a system. They never recognized that SOE was manufacturing standardized equipment in quantity. Little did the Germans know, the bicycles they saw during apartment searches were power stations feeding the communication network they were trying to destroy. The bicycle charger's first major deployment was in France during late 1942. SOE agent Peter Churchill established a network in the Riviera region and received a bicycle charger in a supply drop. For the next 14 months, Churchill maintained regular radio contact with London by charging his batteries through pedaling sessions disguised as morning exercise. German direction-finding vans detected his transmissions repeatedly, but his intermittent power source usage, never connecting to the grid, made him impossible to trace through electrical consumption monitoring. Churchill's network coordinated 23 sabotage operations using radio communications powered entirely by his bicycle charger. He transmitted intelligence reports, received operational orders, called in supply drops, and coordinated timing with other cells, all without ever connecting to municipal power. When German searches of his apartment building increased in frequency, he continued operating because the bicycle in his room looked like innocent exercise equipment. In Holland, a resistance cell in Amsterdam used a bicycle charger to maintain one of the most active radio networks in occupied Europe. The operator, known as Karl, transmitted daily reports between October 1942 and May 1944, over 500 transmissions powered by the bicycle charger. German counterintelligence knew a prolific radio operator was active in Amsterdam and devoted enormous resources to finding him. They monitored electrical consumption across the city, looking for power signatures of radio transmissions. They found nothing because Karl's power came from pedaling, not the grid. Karl's operational security was extraordinary. He varied transmission times, changed locations frequently, and never transmitted from any location connected to municipal power. His bicycle charger made this independence possible. He could operate from safe houses without electricity, from warehouses, from rural barns, anywhere he could set up the bicycle. The Germans eventually caught him through betrayal rather than technical tracking. Even after capture, during interrogation about his power source, German officers refused to believe a bicycle could generate sufficient power for radio transmission. The chargers enabled radio operations in remote rural areas where electricity was unreliable or unavailable. A resistance cell in rural Norway used a bicycle charger to operate from a mountain cabin with no electrical service. For 8 months, they transmitted intelligence about German naval movements while living completely off-grid. German direction-finding attempts triangulated their general area but couldn't pinpoint them because there was no power infrastructure to monitor. The chargers proved especially valuable for mobile operations. A Belgian resistance team mounted a bicycle charger on a cart looking like a mobile repair stand. They'd set up in different towns, appearing to offer bicycle repair services. While waiting for customers, who rarely came during occupation, they'd pedal the generator bicycle, charging radio batteries. They'd transmit that night from a different location, then move to another town the next day. The mobile setup made them impossible to track because they were never in one place long enough for direction-finding efforts to pinpoint them. In France, as D-Day approached, bicycle chargers became critical for maintaining the increased communication tempo that invasion coordination required. Resistance networks needed to transmit more frequently, requesting supply drops, coordinating sabotage timing, reporting German troop movements. Battery supplies couldn't keep pace with demand. The bicycle chargers allowed cells to maintain operational tempo despite supply constraints. In June 1944, cells with bicycle chargers transmitted an average of 40 times per month compared to 15 times per month for cells dependent on battery drops.
Not every deployment succeeded. One agent in Denmark was betrayed by a neighbor who became suspicious about regular pedaling sounds from his apartment. The neighbor reported strange nighttime exercise habits to local police, who investigated and found radio equipment. The agent was executed. But the incident was isolated. Most neighbors hearing pedaling sounds assumed exactly what they were meant to, someone staying fit during hard times. The bicycle chargers also powered other covert equipment beyond radios. Some cells used them to charge batteries for hand-cranked printing presses producing resistance newspapers. Others charged batteries for photographic equipment used to copy documents. The chargers became general-purpose power sources for any operation requiring electricity without grid connection. By war's end, approximately 300 bicycle chargers had been deployed across occupied Europe. They powered thousands of transmissions, coordinating sabotage, delivering intelligence, and maintaining communication links that transformed isolated resistance into coordinated forces. The Germans never realized that pedal power was undermining their control, that the exercise bicycles they saw during searches were energy independence disguised as fitness equipment. What if I told you that German soldiers watched agents charge radio batteries through pedaling and saw nothing but people exercising? The bicycle charger revolutionized resistance radio operations by eliminating battery dependency. Before their introduction, cells operating radios faced constant power anxiety, transmitting sparingly to conserve batteries, sometimes going silent for weeks when supplies didn't arrive. After bicycle chargers were deployed, transmission rates from equipped cells increased by 150% on average. The difference was confidence. Agents knew they could always recharge, so they transmitted when intelligence was available rather than when battery levels permitted. The strategic impact extended beyond individual cells. Bicycle chargers made agents difficult to track through power consumption monitoring. German counterintelligence relied heavily on electrical grid surveillance to locate radio transmitters. When operators used grid power, the distinctive transmission signature, brief high power spikes, was detectable. Grid monitoring led to dozens of arrests in 1942-43. But bicycle-powered transmissions were invisible to grid monitoring because they never connected to infrastructure Germans controlled. This invisibility forced Germans to rely entirely on direction-finding vans, which were far less effective for locating intermittent transmitters. The chargers also provided operational flexibility. Agents could operate from locations without electricity, rural safe houses, abandoned buildings, remote camps. This geographic flexibility made networks more resilient. If urban safe houses became compromised, operations could shift to rural areas without losing communication capability. But limitations were significant. The physical effort required was substantial. Charging batteries to full capacity required 30 minutes of continuous moderate pedaling, roughly equivalent to riding 8 kilometers. This was exhausting for agents already stressed, undernourished, and operating under constant fear. Some agents simply couldn't maintain the physical effort required, especially elderly operatives or those weakened by malnutrition common during occupation. The charging time created vulnerability. 30 minutes of pedaling in one location meant 30 minutes when the agent couldn't watch for threats, couldn't move quickly if danger appeared. Some cells implemented two-person operations, one pedaling while another maintained watch. But this doubled the number of people who needed to be present, increasing exposure risk. The bicycle chargers were bulky. While disguised as exercise equipment, they were still large pieces that couldn't be hidden quickly. If German soldiers burst into an apartment during a search, the bicycle couldn't be shoved under a bed instantly. Most agents kept bicycles in positions they'd naturally be as exercise equipment, bedrooms, spare rooms. But in cramped apartments or shared housing, explaining a stationary exercise bicycle wasn't always simple. Mechanical reliability was inconsistent. The alternators were precision devices exposed to dust, humidity, and temperature extremes. Bearings wore out. Friction rollers deteriorated. Electrical connections corroded. The average bicycle charger required maintenance every 3 months, replacing worn parts, cleaning contacts, relubricating bearings. Equipment failure at critical times left agents without charging capability until repairs could be arranged. The rechargeable batteries were heavier and lower capacity than disposable batteries. For stationary operations, this weight penalty was acceptable, but for mobile agents or those who needed to evacuate quickly, carrying heavy rechargeable batteries was a burden. Some agents kept both rechargeable packs for regular use and disposable batteries as emergency backups. The pedaling was not entirely silent. While the alternator itself was quiet, the bicycle frame sometimes creaked, the chain made soft sounds, and heavy breathing from effort was audible. In apartment buildings with thin walls, neighbors could hear the activity. Most neighbors assumed exactly what they were meant to, someone exercising. But suspicious neighbors occasionally reported strange regular activity that drew German attention. Despite limitations, the bicycle charger's value was immense. It transformed radio operations from battery-limited to energy-independent. It made agents untraceable through power grid monitoring. It enabled operations in locations that otherwise wouldn't support radio communication. Post-war analysis of captured German counterintelligence records revealed how devastating the bicycle chargers were to detection efforts. Multiple reports mentioned frustration with radio operators who transmitted regularly but showed no corresponding electrical consumption patterns. German technicians couldn't understand how transmitters were powered without grid connection. Some reports speculated about exotic power sources, including rumors of advanced battery technology. They never seriously considered that bicycle power was the answer. It seemed too simple, too low-tech for sophisticated spy networks. That dismissal of simple solutions was exactly what made the bicycle charger brilliant. It wasn't exotic advanced technology, it was a bicycle and an alternator, components available to any competent engineer. But applied cleverly, disguised perfectly, and deployed systematically, it became a weapon that killed German counterintelligence effectiveness. The bicycle charger never fired a shot, never exploded, never struck directly at German forces, but it killed German counterintelligence efforts by making spy networks energy independent and untraceable. Every radio message powered by pedaling was intelligence shaping Allied operations. Every coordination enabled by bicycle-charged batteries was sabotage disrupting German logistics. Every transmission avoiding detection through grid monitoring was a network that survived to fight another day. The bicycle charger reminds us that World War II's most effective innovations often solved unglamorous problems. Not how to make bigger explosions or faster planes, but how to charge batteries without detection. Not advanced technology, but simple mechanics applied brilliantly. A bicycle and an alternator combined with clever disguise became a weapon that killed German counterintelligence effectiveness, while German forces searched for power sources they'd never recognize. The agents who peddled these bicycles understood they were maintaining the lifeline between occupied Europe and London. Every wheel revolution stored energy that would become communication. Every charging session was preparation for transmitting intelligence, receiving orders, coordinating attacks. They pedaled while German patrols walked past outside. They generated electricity while guards searched apartments. They maintained independence while the enemy controlled every power grid. So remember the engineers who turned exercise equipment into power stations. Remember the agents who pedaled through exhaustion to charge batteries, trusting their security to mechanical disguise. Remember the bicycle that looked like fitness equipment but functioned as liberation infrastructure. That's the genius of British World War II innovation. That's the weapon that killed through independence, powered by pedaling, invisible as exercise. From buttonhole cameras capturing secrets, to biscuit tin radios coordinating attacks, to spike letterboxes collecting intelligence, World War II weapons reveals how British intelligence turned innocence into lethality. Subscribe now for more incredible stories of weapons that killed through perfect disguise and brilliant deception.